Before this, voltage were fluctuating, but now voltage are stable. Assalamu alaikum wa rahmatullahi wa barakatuhu. Friends, welcome back to my channel. In this session, we will repair this CLM DC 150 watt 24 volt stabilized output voltage LED power supply. If you don't have good experience in electronics, never try to repair because here are live voltage. Always take care of all the safety. We will use AC voltage and I will apply power using series lamp. Line neutral and third pin earthing point. No indication on the lamp. DC voltage. Fluctuating voltage. So its output is fluctuating. We will see what is the reason here. When its back cover is removed, never touch any component until we are confident that there are no voltage on its smoothing capacitor. That is this capacitor. We have 24 volt, so it is now approximately in safe limit. But we will discharge it. Yes, this transistor is damaged. Now we will see the behavior of circuit and then we will see how we can fix it. Never touch any component in primary side where power is applied. We can see PFC circuit not started. This is the first symptom. Output voltage fluctuating. Yes, it is damaged. And if you check this pin, it is connected to this rectifier signal diode. It is also short circuited. its cathode is in this side. Its cathode this side. It is normal signal diode 1N4148. This pin, this diode is good. This diode is also damaged. Its diode, its cathode in this side. And if this diode is damaged, we will check these resistors. This end connected together, this end together, that means both resistors are in parallel. 22 ohms, 22 ohms, two resistors in parallel. That must be 11 ohms. Because two resistors same value in parallel, the resistor value must be 11 ohms. But here it is giving 206 ohms. That means these resistors are also damaged because these are also connected in the same path. In the same path that is shorted here. From here to here and to this line. And if we check this, it is a negative line of this capacitor. Yes, VCC section is damaged. So it is reaching to these points. These are VCC section voltage. Let's remove these resistors. I will remove these two resistors, the same size code, but it is 20 ohms. No problem, our resistor is 22 ohms. Here it is 20 ohms. I will use these two resistors. Then here signal diode. One diode here. These auxiliary voltage are reaching here to this rectifier, positive voltage from here to this pin. That means it is collector. If it is NPN, if we check this emitter pin, if it is emitter, that time it is reaching here, then to this rectifier. So positive voltage from here will reach here, and it is connected to VCC pin, VCC capacitor here. No short circuit on VCC capacitor. So that means we need an NPN transistor, because 1K resistor with this rectifier, positive voltage are provided to base, Positive base biasing, that means it is positive, less positive and negative. NPN transistor. We need base pin here. That means this pin must be base emitter collector. 0.609, 0.628, 0.628 emitter pin, 0.615 collector. That means this transistor is good. Now I will align it. Before this IC was working in reboot mode. It's this VCC power switch failed, damaged, which caused to damage these resistors. This diode, this path was damaged. In this power supply, the VCC voltage were missing. When VCC voltage are missing, then this IC will work in reboot mode. It will work in reboot mode, but PFC section will not take start because this chip VCC voltage are provided from this transistor. Now we will see, might be there is something wrong here. Now we will verify. Because this VCC capacitor is providing power to both chips. We will check voltage on this capacitor first. Before this, we did not check voltage on VCC capacitor, but when this section is damaged, there must be fluctuation on this capacitor. It is a basic checkpoint because we detected visually. If there is no visual damage, after checking voltage on this capacitor, we must verify voltage on VCC capacitor. Before this, voltage were fluctuating, but now voltage are stable. Now we will check voltage on this capacitor. Before this 330 volt, but now the voltage are boosted. That means its PFC section started working. What was the reason behind not working? That this VCC section, it was not providing voltage to this chip. If this chip will not receive voltage, it will not work. When it will receive VCC voltage, that time it will take 3 more steps. The first, it will check voltage on input line, that are bridge rectifier output most of the time. Then it will check voltage from this capacitor, from this resistor network, positive terminal. It will sense these voltage, how much voltage are there, what is the difference between input voltage and capacitor voltage. If there is difference, that time it will switch the power MOSFET, that is PFC section MOSFET. That MOSFET will take drive, and at source pin there is a power resistor, that is to measure current flowing in the PFC section. That dropped voltage will reach here across the current sense resistor, so that it will adjust its duty cycle to maintain 365 volt to 380 volt on main capacitor. Now our circuit is stable and VCC section is good. Now the output is stable. If there is fluctuation on output terminal, when load will be connected, what will happen? PFC section will not provide enough voltage at DC rail. In PFC power supplies, this resonant PFC controller has a very limited duty time that can be adjusted for voltage regulation. In result, this power supply will start fluctuation. Maybe it will damage the load, or maybe it will damage itself, or maybe it will keep fluctuating. If you enjoyed this video, give a thumb up. If you have any question, please write in the comments. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.